Are you ready? We're going to get into the periodic table even more. So in class, you're going to choose your participation method. The modern periodic table is arranged by what? Do you remember? Hopefully. Yes, atomic number. What determines the chemical properties of an atom? The number of valence electrons. How many valence electrons do stable atoms have? 8. Oh, except helium, remember, 2 total. 8 valence, 2 total. If an atom loses 1 electron, what will its charge be, or oxidation state? Well, it would be +1. If an atom gains 2 electrons, what will its charge be, or its oxidation state? -2. What is the name for group 18? Noble gases. What is the name for group 1? Alkali metals. What is the name for group 17? Halogens. What is the name for group 2? Alkaline earth metals. All right, now we're going to look at metals, nonmetals, and metalloids on the periodic table. So metals, most of the elements on the periodic table are metals. Everything in pink here, metal. So metals, here are some examples. What are some properties? Here's what you should memorize. Okay, they are good conductors of heat and electricity. So our wires, our pipes, things like that, they're made of metals. They're ductile. So that means they can be squeezed out into wires. They're malleable, like mallet, hammer. They can be hammered into thin sheets. Think of aluminum foil. They have luster, they're shiny, and they're solids with one exception, mercury. So we already discussed where to find alkaline metals and alkaline earth metals on the periodic table. What about the rest? Okay, so well, there's transition metals. We did talk about those briefly. That's groups 3 through 12. They're the D block. They do have metallic properties, so they're conductors, they're ductile, they're malleable, they have luster, but they don't have that same repetitive pattern of the same number of valence electrons. They also have less reactivity. In fact, some of them are extremely unreactive, like gold. That's why we make jewelry out of it, because it doesn't tarnish like other metals would. Here we go, transition metals. Now, we have lanthanides. That's actually in period 6. It's the first row of the F block elements, so it starts with lanthanum. That's why it's called lanthanides, okay? So you can look right here, that first row of the F block starts with La, lanthanum, so it's called lanthanides. And then below, in the bottom row, are actinides. So it's that second row of the F block. Most of these are radioactive. Uranium is probably the most well-known, so you should know where uranium is on the periodic table. So there's the actinides. Again, pay attention to where uranium is. Now, radioactive elements, which means they have no stable isotopes, are going to have an atomic mass in parentheses. So you can see it here like this. So that means that atomic mass is our best guess because none of the isotopes are stable, or they have an extremely short half-life, so they're not around for long enough. So you can always tell if an element does not have any stable isotopes because its atomic mass will be in parentheses, like best guess. There are some other metals, so if you look, we did, this is, let me just change my color here. Okay, this one, group 1, alkali metals. Group 2, alkaline earth metals. Groups 3 through 12, transition metals. Down here, lanthanides. Down here, actinides. But then we have this little section right here, colored in this dark blue. Those are kind of the other metals, okay? So in general, we're going to have metals on the left side of the periodic table. Now remember, this is what it would look like if we set it up right, so then it would make sense, okay? Hydrogen, an exception, that is not a metal, but everything over here is a metal. So that's a lot, okay? All right, what about nonmetals? So in this one, nonmetals are blue. Notice hydrogen. Okay, so nonmetals are on the right side of the periodic table except for this one, hydrogen. Um, and it's most of them on that side. So some examples of nonmetals, okay? What are some properties? Well, instead of being conductors, they're insulators. So they don't conduct heat or electricity. They tend to be dull and brittle. So if you try to hammer them into a sheet, they just break. Some of them are solids, some are liquids, and some are gases. They have multiple states of matter. Now, the noble gases usually were not included in nonmetals when we're talking Regents questions, because it will say, like, which of the following is a nonmetal? And there will be a nonmetal, and then there will be a noble gas. So essentially it's saying don't pick the noble gas as an example of a nonmetal because it's not reacting, okay? So they're kind of in their own category. Now there is a reference table which can help you if you forget. So if you panic, you're like, oh my God, what side of the table is metals, which is nonmetals? So table J literally says these are metals and these are nonmetals. And if you find them on the periodic table, you're like, oh, phew, thank goodness. Panic for a moment. Nonmetals are on the right side, metals on the left side. Now we're almost finished, but there are metalloids. What the heck is that? Well, here are some examples. What are metalloids? Well, they have properties of both metals and nonmetals. So we call them semiconductors. They still are brittle like nonmetals, but they have luster like metals. So they're kind of like the in-between, okay? It's kind of like a metal, but not quite. Kind of like a nonmetal, but not quite. So where do we find them, okay? On the periodic table, and I'll show you on your periodic table in a moment. But right here, you can see right here, 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 here. And sometimes we include this one too, okay? So these two at the bottom are kind of the sometimes, but all of the other ones. So let me show you on your periodic table because that's the one you get to use. All right, so here it is. So do you see this dark line? It's called the staircase. This is the dividing line between metals and non-metals. Okay? So metals are on this side of the staircase. Non-metals are on this side. But if it's touching the staircase, it could be a metalloid. So kind of a metal, kind of a non-metal. So boron is the first one that's touching the staircase. Now, aluminum right here, it is touching the staircase, but it is not a metalloid. So please remember that. Silicone, yes, it is a metalloid and touching the staircase. Germanium, arsenic, antimony, tellurium, yes. Now, these two, remember, sometimes we count them and sometimes we don't. Most of the questions you will see on the exam will include boron, silicone, germanium, arsenic, antimony, and tellurium. But these two are touching the staircase, so we don't discount them, okay? Metalloids on the staircase, with one exception that is on the staircase but is a metal, remember aluminum. So almost all elements on the periodic table are solids at room temperature and STP. So what the heck is STP? Well, if you remember, that's in table A. STP stands for standard temperature and pressure. So it's going to be 0 degrees Celsius or 273 Kelvin. So we have some temperatures that you just got to file them away and remember. STP 0 degrees Celsius. But guess what? You don't have to memorize that one because that one I just showed you was on table A. You do have to remember this, that water both melts and freezes depending which way it's going at 0 degrees Celsius. Water will boil or condense at 100 degrees Celsius. Room temperature is 20 to 24 degrees Celsius. If you just remember 20, that's fine. That's usually what I do in my head. And there's in Fahrenheit because that might make more sense for you. And just an FYI, this is not ever tested on the exam, but just so you know, normal body temperature is about 37 degrees Celsius, or that's 98.6 degrees Fahrenheit. Okay, you have to know how to do temperature conversions, but there's a formula. So in a later unit, we're going to do more with conversions. For now, realize that if you want to change something into from Celsius into Kelvin, all you do is add 273. So STP was 0 degrees Celsius, so you add 273. Water melts and freezes at 0, add 273. Now you have Kelvin. Water boils and condenses at 100 degrees Celsius, add 273. Now you have the Kelvin temperature. Room temperature 20, add 273. Now you have the Kelvin temperature. Okay? Same for normal body temperature. Now, remember I said most of the elements on the periodic table are solids? Yeah, look, all the green ones are solids. Okay? So the yellow ones are gases, and the blue ones are liquids. So group 17, halogens, remember, is special because it has elements in every single state of matter. Top two are what? Gas, bromine, liquid, remaining solid. Now, Table S can actually help you determine any state of matter you were ever asked. If you're like, what state of matter is this element in at this temperature? Just use Table S. So you have melting point, which means that's going from solid to liquid, or from liquid back to solid. And boiling point, same thing, from liquid to gas or gas back to liquid. Okay, now what? So below melting point, the substance is a solid. So that means it hasn't gotten to that temperature to be able to melt, so it's a solid. So right there. If the temperature is below that temperature, it's a solid. If the temperature is between the melting point and the boiling point, that means it's melted but not boiled. So it's going to be a liquid. And then above the boiling point, a substance will be a gas, okay? Because it has already boiled, so it's a gas. So if a question, say for example, said, what state of matter is sodium in at room temperature? Well, remember that was 20 degrees Celsius at 273. We've got 293 Kelvin. Find where sodium is on the list and put 293 where it belongs. Like, is it, so right here, here's sodium, right? So put 293 where it belongs. Does it go below 371? Is it between those two numbers? Or is it above 1156? Well, it goes right here, right? It's below 371, which means it is a solid. Let's try another one. What state of matter is fluorine at STP? Well, look at table A. STP is 273 Kelvin. Find fluorine, and you're going to put 273 where it belongs. Is it below 53, between 53 and 85, or above 85? Well, it is above 85, which means it's a gas. Okay, let's try another. What state of matter is phosphorus at 318 Kelvin? Well, this time I was given the number, so all I have to do is find phosphorus, right? And then I decide where to put 318. Below here, between here, or above? Well, it's between, which means it is a what? A liquid, okay? You also need to remember the diatomic elements. That just has to come from your brain. The phrase is Brinkelhoff.
Br, bromine, I, iodine, N, nitrogen, Cl, chlorine, H, hydrogen, O, oxygen, F, fluorine. You can see where they are. Hydrogen, that kind of one oddball hanging out by itself. And then you have this little shape right here, kind of like a 7. Huh. And there's 7 diatomic elements. If you remember hydrogen, and then you just got to make this 7. And if you remember halogens, it's always involved in weirdness. Okay, so there you go. This type of element is a good conductor. Metal. This type of element is usually dull and brittle. Nonmetal. This type of element has properties of metals and nonmetals. The metalloids. This type of element is a poor conductor. A nonmetal. This type of element is on the left side of the periodic table. Metal. This type of element is malleable. Metal, remember that means it can be hammered into thin sheets. This type of element is a semiconductor. That is a metalloid. All right, I hope you learned some more about the periodic table.